All right, now we're going to try a couple of more illustrative examples of more involved polar curves. Okay, so we're asked to sketch the curve associated with the polar equation r equals 2 cos theta. Okay, and then we're tasked with finding the Cartesian equation for this curve. So we're going to start by sketching. We're going to go back to nuts and bolts here and actually find some coordinates and plot them. So I've kind of like tried to make my table a little bit clearer to read. I'm going to start by plotting this point. I'm going to call it A. Okay. A is going to be at angle 0, 2 out. Okay. So let's make this 1 and this will be 2. Okay, so we've got this sort of polar curve here that's gonna, or like this polar plane that's kind of making things a little bit easier for us to see. Okay, so this is 2 out, and so I'm going to call this point A. Great. All right, let's just sort of maybe change colors here. Now I'm going to look at pi over 6. Okay, so pi over 6, that is going to be, well, it's before pi over 4, and I'm going to kind of like maybe make this ray go all the way out like this. And then I'm looking at root 3, that is less than 2 in. We'll put it, let's see, maybe it's about 1.73. So here's 1.5, here's 1.75, so around here. Okay, so there's my point B. Okay, very nice. Call this pi over 6-ish. Moving on, square root of 2, that's 1.41 about. Okay, this is supposed to be B. This will be C. This will be B, excuse me. Now, pi over 4, we do have a ray for that. That's right there. I will undo it so it's a little easier to see. I'm going 1.4, so that's a little bit inward here. We're going to call that point C. Very nice. Let's keep going. Don't need to simplify 1. That's very good. Let me kind of maybe make the ray 1 over 3, somewhere around there. I think it's a little bit too much. Somewhere like that. And now, so it's pi over 3, and I'm in 1, and so I'm tracing along this line here, and I get this point. I'm going to erase those. Okay, and that is my D. And then pi over 2, very happy to see that. Let's go with E. Pi over 2, and back to 0 here. Okay, so this is my point E. And so I'm like tracing around here, and it seems to be starting to kind of make this sort of semicircular angle. And I am going to largely basically leave this to you to kind of fill in the remaining points. Please do. But what happens if we want to like do this a little more precisely is, well, we start to get all of these points. We trace them around, and we're getting something that looks like a circle. Okay, it really, really does. It looks like a circle. Question though, is it really? Well, let's find out. We're going to find the Cartesian equation. Well, we know that r is equal to 2 cos theta. That's coming from here. We know that x, well, that is r cos theta always. That's how we convert. So this is 2 cos theta, which is 2 cos squared theta. Great. We actually, well, do this, I'm going to put a pin in that for the moment. y. What is y? Y is r sine theta. And so this is 2 cos theta sine theta. To be very clear, this 2 cos theta is this r and is this r. Now we have to lean a little bit on our identities, which maybe is never the most comfortable the first couple times you do it. But 2 cos theta squared, this is 1 plus cos 2 theta. And 2 cos theta sine theta, this is sine 2 theta. These are identities. Okay, and what does that tell us? Well, x is equal to 1 plus cos 2 theta. So x minus 1 is equal to cos 2 theta. Y is equal to sine 2 theta. And so if we do x minus 1 squared plus y squared, what do we get? This is 1, right? This is 1. This is our circle of radius 1 centered at 1, 0. Exactly as we would, as it looks, right? It looks like this is a circle that's centered at 1, 0. And we've just shown that based on our knowledge of how polar and Cartesian coordinates convert between each other. Okay. Let's